Welcome to today's lesson, and today I want us to cover vectors. Vectors 1, and we start with introduction. So, to understand what is a vector, let me draw a line here, the compass here. So that's a compass. We have that, and we have this is north and this is east direction, and then we have another point here which is B. We can say we have a point here B, and this is our point A, and this angle is the angle here is 0.45 degrees. Now, we need to describe B, and it is 50 kilometers from A. So we can describe B in reference to A and say B is 50 kilometers from A. B is 50 kilometers from A. That is one way we can describe B. The other one is B is northeast of A, so we can say B is northeast of A, and we have the other one is we can describe is B is 50 kilometers northeast of A. So the third one best describe position B. Why? Because it specify the distance from A and the direction. So when we describe so this is what we call a vector. So a vector is a unit, or we can say a vector describe a magnitude and direction of a quantity. Direction of a quantity. So we can say Roman number 3 describe a vector. Example of vector include velocity, it includes acceleration, it includes force, and others. So then we can say a quantity that only has magnitude, that has only magnitude is called a scalar. Example of scalar is mass. Weight is a vector. Then we have distance, and we have temperature, we have time. So in summary, we can say that a quantity that have magnitude is the same as size, and magnitude and direction is known as a vector. A quantity that has only magnitude is known as a scalar, and we have given examples of that. Next, we look at representation of vector. representation of vector. Now, a vector, since we have defined a vector to be represented by a magnitude and direction, when you draw a vector, you must indicate the direction. For example, if this is vector AB, then it has direction. Then it has magnitude. So a vector normally has a vector, a magnitude and direction. Then we can call this vector A, or we also use A with a zigzag line underneath. So whenever you see this zigzag line written in this kind of way, then you understand it is a vector. So when you draw a vector, you must indicate the direction. You must indicate the direction. From there, we look at equivalent vectors. We look at equivalent vectors. Now, equivalent vector, we say that two vectors are equal if they are facing the same direction and have the same magnitude. For example, if I draw a vector like this, and I call it, okay, I have shown the direction, then I call it, I can call it vector A. Let me show you, vector A. So that vector, we can call it A. Now, if I make another vector here, which is the same as A, and I call it vector B, you can see that vector A and vector B are facing the same direction and they are equal in magnitude, because what I have done here, I have duplicate vector A. So we say two vectors are equal, if they have the same, if they have equal magnitude, and same direction. So I hope that is clear. When we are representing the magnitude, we use two vertical lines. For example, the magnitude of vector AB, like that. That is, these two lines, two vertical lines, represent the magnitude. So in this case, we are saying the direction of A is the same. So we have, and the magnitude of A and B are equal. So that is how we represent the magnitude. From there, we have addition of vectors. Addition of vectors. We have addition of vectors. Addition of vectors. Now we can add two vectors. So we can have, let's say, a vector here. So that's a vector, and we can call it vector AB. Let's call it vector AB. So it shows the direction and the magnitude. So that is vector AB. Then we can have another vector here and call it, we can call this vector, let's call this vector BC, and this is the direction. So that's another vector that, so when you add vectors, then what do? You bring this vector here and you put it. So when you add two vectors, they form a vector from A to B to C. Then we can have now one vector which is a combination of the two, and we have, this is now the vector that which is a combination of two. Remember, in vectors we describe a vector describe movement. So when you add, actually if we say this vector is A and this vector is B, then this vector is A plus B. So that is how we add vectors. That is how we add vectors. So if you have a vector here, we put a vector there, a vector there. These are two vectors. You can say this is that's a vector. We can say this is A, this is B. Then the resultant vector, or the addition of the two vectors, this vector is vector A and B, A plus B. So that is how we add two vectors. From there we have, we can have an example. Let's say we have, so that is generally introduction of vectors. So let's have examples here, and they say, use a graph paper to illustrate the sum of the following vectors. So we have example. Our example says use use graph paper. Use graph paper to illustrate the sum of the following vectors. And we have A plus, we have, let's do another example. I don't think we need. Example 1, we have vectors here, A, B, C, and D. So we have vector A in that direction. So we can say, you can say the direction of A and B are not the same. So A is not equals to B. What about vector C, this vector here? They are equal in magnitude, but they are opposite in directions. So A and D are in opposite direction. So they are not equal. Then we have E and F. Same direction, same magnitude. So we can say E and F are equal, or what we are calling equivalent vectors. So that is just an introduction of what is it about. You also look at zero vector. We look at zero vector. So zero vector is when we have two vectors which are equal but different, facing different direction. So for example, we have a vector, we can have vector A. That vector, we can name it A, and we can have another vector B, that is 1, 2, 3, 4, 5, 6, 7. So we have another vector B, and we can just let's Let's duplicate this one. So let's say we have this vector B, so we can label this vector B. So you can see A and B are equal in magnitude because actually I have duplicated, but the different direction. This means that if you bring B on top of A, they will cancel each other. What does that mean? It means that vector A is equals to minus vector B, and therefore we have A plus B is equals to 0. A plus B is equals to 0. That is what we call zero vector. So 0 vector is that. From there, we look at multiplication. We have multiplication of vectors. Multiplication of vectors. Now, let's create a vector here and call it our vector A, like that. So that's vector A, and we can call it vector A. Now, suppose we have another vector like this one. We can duplicate that. And we have 3 vectors. So we have our vector A, our vector A. If we combine these 3 vectors, so we bring our A here, we take our A there, so that's another A. We take this other vector there, and we say it is our A, so we have combined. This means that if we label this vector A, and A, we have B, we have C, we have D. We can say that AD, now the complete vector AD is equals to A plus A plus A. So that gives us what? 3A. 3A. Remember we say that we can use that as to mean or to indicate it's a vector. So when you write a vector, that is, for example, PQ is equals to K vector B. K is known as a scalar. We call it scalar multiple. So here 3 is a scalar. We have multiplied that vector by 3, so 3 is a scalar. We have a negative scalar. That is, when you have a vector, you can draw a vector here. We have a vector which we can put that. So this vector, we can label it B. So if we duplicate that vector, we can have another B. We can have another B. So this is vector B. This is vector B. Now, suppose now we rearrange our vector like this. We rearrange our vector like this. We arrange it like that. Let's put that together. I think it is giving me problems. So we just come here and say so that is our vector. So we make another vector B, and we make another vector B. So that means that those are 3B. Suppose now we say this is our vector A, we have B, we have C, not C, not there, we have C, and we have D. if we change the direction of this vector like that, change the direction of that, we change that, we change that. Now you see what has happened. Our vector A has changed the direction. So now if we describe our AD, it is equals to minus A, because we are moving from this direction A to D. Then we say it is minus A plus minus A plus minus A, which is equals to minus 3A. So A3 is referred to as negative factor. Negative scalar, not factor, negative scalar. So when the number multiplied by a vector is negative, then we refer to it as a negative scalar. I hope that is clear. Then before I move again, we have, let's just do it, this is a negative scalar. Then we have zero scalar. Not like that, zero scalar. Zero scalar is when we multiply a vector by 0. So we have A, 0 multiplied by, this is 0, is the same as A multiplied by 0 is equals to 0. So when you multiply a scalar a vector by 0, then that is when we have 0 scalar. Let's have an example. We have, let's say, example, we can say, we are going to look at an example here. So we say, this is example 1, vectors A and B are given below. Use a grid to construct B minus A. Use the grid to construct we have A, B minus A, and we have B 3A minus 2B. Okay. Now with that, let me check whether I'll be able to get a graph which will help us to do that. So that is my graph, which I'm going to use to construct that. So let me make it a bit smaller so that it fits on my board. So we can have vectors. Let's say we have vectors like that, and we have a vector like that. So we call this A, this is vector A, and this is vector B. Let me combine them so that I can be able to work as a single unit. So we now bring our grid again, and those are the vectors that we have. So you can see, so we want to construct. So we can, what we can do is that, suppose we are told now, we are told B minus A. So we have B. We can take now B here at that is we can construct this is A, and we can put it like that. So the vector that you end up with is like that. Remember, this is A, this is B. I think this is B. So this is B. So we want B minus A. So it's B minus A. Then we have our vector here is this. So this is the vector B minus A. B minus A. So that's how you construct that. The other one is 3A. The 3A, what you do is you multiply. You multiply this 3A. So you have a vector, you combine them. We can make it, let's make A a bit smaller so that we can be able to work with it. And we can remove this. So we have our vector A, which we can put it there. And we can have I think that is better. We can have another vector here, which is vector B. So that is vector B, and can combine this. Not like that. Then we bring back our grid. It is like that. We can bring our B there. So when we are told 3A plus 2B, you can combine this. You can say this is our A from here, and we put this other A here, and we put another one there. Okay, and then we have 2B. 2B you duplicate like that, to combine like that. Now we have 3A, so we can now bring our B here, and therefore the vector that will represent this will be the vector that will present 3A minus B. So this is what we have, 3A minus B. So that's how you go about it, and that brings us to the end of that lesson. So let's go to lesson 2. So here are practice questions you can use. We can call them practice questions. So practice questions, you can say number 1, given that T is equals to 2A minus B and R is equals to B plus 3A, find in terms of A and B. Find in terms of A and B. Can put that to denote that they are vectors. The following vectors. So you have A, 2T, B, we have a half R, we have C, we have minus T, we have D is equals to minus 2R, let's just remove that. We have D is minus 2R, E, we have 2T minus 2R, we have F, we have F, we have minus T plus a half R, that is FG, G we have 2R minus T. So you can write those vectors in terms of A and B. Then we have another question here. We can say simplify. We have A, we have 3A plus 2B minus C plus 4 into bracket a half A minus 3 over 2 C, then plus a third 6A minus 9B. You can simplify that. You simplify that by putting the right terms together. You can see we have here we have A. Here we open the bracket, we have A, and here we have A. So you put those A's together. We have B, we have also B here. We have C, we have C. Put those right terms together. Then we have B, we have 2U minus 3V, then plus 2 into bracket W minus U plus 3 into bracket U plus V. You put the bracket. Then we have C, P, put the bracket minus Q plus R minus P plus Q minus R. So you can try those three questions. Remember, this is introduction of vectors, and you have to understand the basics of vectors so that you can be able to get vectors. Even when you get to vectors in Form 3, you have understood the basic. So the next lesson we are going to deal with column vectors and position vectors. And then you see what are position vectors and column vectors.